Good morning. Continuing in our circles unit, unit 10, we've got classwork 4, arcs and inscribed angles. We're going to learn about what an inscribed angle is today. So for our prior knowledge, we're just going to recall that the central angle and its arc are equal. We want to know the measure of arc MN. Well, that's 55 degrees. M to K to N is the major arc, so we're going to take 360 and subtract that 55. It's going to be 305. JML, so JML, give you a second to find it, 180 degrees. It's the semicircle. And let's find this little angle right here. MQL. Well, 55 plus 60 subtracted from 180, that's going to be 65 degrees. Arc ML, 55 plus 65, 120, wait, arc ML, no, that's 65. I jumped it down. LN is 120 degrees. All right, today's lesson, an inscribed angle. So what's a chord? Recall that a chord is a line segment in a circle whose endpoints on the circle. This is the longest chord. So an inscribed angle, when we talk about an inscribed angle, it's an angle whose vertex is on the circle, the vertex right there, and whose sides contain chords of the circle. So a central angle up here is made up of radii. An inscribed angle is made up of chords. And again, see, we have the central angle, the intercepted arc, and now we have the inscribed angle. It's as if you pinched that central angle and stretched it all the way back till it touched the circle. Question 1, name the arc that is intercepted by each inscribed angle formed by the two chords below. So we've got chords AB and chords CB. We've got angle B, and so the arc that's intercepted is arc AC. We've got angle E right here. We've got angle G right here. And sometimes, if I can't see the intercepted arc, I extend out those lines. And what do you notice? They have the same intercepted arc, and that's going to be arc DF. And then we have angle J right here. This arc is going to be a major one. So for angle J, we're looking at arc KHI. And for angle H, we're looking at IJK. In this circle, F, G, and H are examples of inscribed angles. Notice that all three angles intercept the same arc. Let's highlight that. We've got oops, I wanted to do highlight. Oh well. We've got angle F, we've got angle G, and we've got angle H. And notice they all intercept arc JK. So what do you think about those angles? If they intersect the same arc, exactly. Inscribed angles. That intercept the same arc are congruent. Therefore, angle F is congruent to angle G is congruent to angle H. Remember, a conjecture is a guess. We're making an educated guess based off of patterns. So if we have inscribed angles that intercept the same arc, then those angles are congruent. So when I look at this example, if angle E is 75 degrees and it intercepts the arc GH, then what do we know about angle F? The measure of angle F also equals 75 degrees. So how do we measure these angles? Right? We know what they are now. They're made up of chords. They're on the circle. They intercept arcs, but how do we measure them? So let's look at this example. Looking at the arc that corresponds to each angle below, what do you notice between the inscribed angle and the intercepted arc? So we have here, we have measure of angle M equals 64 degrees. The measure of LN, that arc, equals 128 degrees. In the second example, angle M is 49 and LN is 98. And in the third example, this might be more clear. Angle M is 90 and arc LN is 180 degrees. Well, the inscribed angle is half its intercepted arc. Or you could say the arc is twice the inscribed angle. So there are multiple ways of proving it, and in class you would have done some, work with tracing paper and protractors and all kinds of stuff, but we don't have those tools with us, so we're going to do a different kind of sort of smarty pants proof to prove to ourselves that in fact the inscribed angle is always going to be half its intercepted arc. So look to the right here. We've got line segment CB, which is the diameter. So if CB is the diameter, then we know that PB, PA, and PC are all radii. That make sense? All right, so if we know that PA, PB, and PC are all radii, and radii are all the same length, what kind of triangle is CPA? Well, it's isosceles. sides are the same length. They are the radii of the circle. So I'm going to call angle C right here. I'm going to call that x degrees. If it's an isosceles triangle, angle A must also be x degrees because the base angles in an isosceles triangle are congruent. We're going to go back to something we learned earlier. I keep giving you these problems in the warm-up. Remember the external angle theorem where it says, when are we ever going to use it? We're going to use it now. A, B, C. And then this angle, the exterior angle is D. You could do triangle sum theorem, you could do linear pair, but the exterior angle theorem says that A plus B equals D. Well, looking at this isosceles triangle, x plus x equals this angle here, 2x. And if that central angle equals 2x, then arc AB has to equal 2x. So, by exterior angle theorem, we've been able to prove, and with the isosceles triangle theorem, we've been able to prove that angle C is x and angle AB is 2x. It's twice the size. The arc AB is twice the size of angle C. So we would write the measure of angle ACP is half the measure of arc AB. You can write it that way, or you could say no, I want to leave it like that. And we know that because x is 1/2 of that 2x. Angle x is half of 2x. All right, so here we go. The measure of an inscribed angle is equal to half the measure of its intercepted arc. All right, so we want to find the measure of the blue arc or the blue angle. So in A, we're given the measure of angle R. The measure of angle R is 90 degrees. It's half the arc. So the arc STQ must equal 180 degrees. In problem B, we're given angle Y equals 115 degrees. That means arc ZWX must be twice that, or 230 degrees. And if we know in problem C, arc in P equals 100, what do we know about the measure of angle M? It must be 50 degrees. Supposed to draw a center here. The central angle and the arc are the same. The inscribed is half. Let's find some of these. Let's do a little bit of practice before you have to do it on the homework. Angle T right here. What is the measure of angle T? (24 degrees). Arc QT, we're talking about this arc right here, That's 100. And so the question is, what's the measure of arc QR? Well, if this is the diameter of the circle, and you know on your protractor that this is 180 degrees because it's a semicircle, arc QR must be 80 degrees. Let's look at the next one. We want to find the values of A and B. So for arc A, that's going to be 120 degrees. But for angle B, we have to add on this 30-degree arc. So 120 plus 30 is 150 degrees, and half of 150 degrees is 75 degrees. Let's examine these diagrams below. So these are pretty much your typical examples of inscribed angles. First one should be easy. X has got to be half of 118. So X is 59 degrees. I had this problem yesterday. There it goes. I don't know what's going on with my computer. It keeps doing this. All right, X is 59 degrees. I think it doesn't like me if there's a little box in there. It doesn't allow me to write inside. So I'm actually going to just sort of leave these, and when I scan the key for you, they'll be there. Let me just go ahead and write the answers down here. So for A, let's see if it lets me. No, it's not going to let me. All right, another, there we go. A, X equals 59 degrees. Or B, X equals 82 degrees. So you try and then check the answers down here. For C, X is 180. Y is 156. E is 24. Remember the semicircle on problem C. Problem D, X equals 56. Y is 28. He's a tricky one. Make sure you're using your exterior angle theorem, right? And for F, remember they share the same arc.